Okay, so we were we were finishing off. We have finished off work power energy, right? For rigid body dynamics. Next is angular momentum. Okay, so what is angular momentum? Where does it come from? Okay, and details about it. Yeah, so first, what is angular momentum? Uh, so if you remember the discussion that we had when we were talking about linear momentum, there was a logical succession of steps after which we arrived at the concept of linear momentum. And the logical succession of steps was that we were trying to define Newton's second law for a collection of particles. And we said that, look, the net force on the collection of particles must be the sum of the forces acting on the individual particles of the system. And when we found the sum, we found that in that sum, there are some forces which can be classified as internal in the sense that they are acting between two particles within our chosen system. And some forces can be classified as external, that is, forces acting from outside our chosen system. And then we applied Newton's third law to say that, look, the sum of the internal forces, they always become zero, because if I am calculating the force on each and every object inside the system, then when I talk about object 1, then of course I have to talk about the force applied by object 2 on object 1. And then when I go on to talk about object 2, then I have to talk about the force applied by object 1 on object 2. And these two forces, according to the third law of Newton, are equal and opposite, and they cancel out. So all the internal forces, they cancel out, and we arrived at a equation which was that the sum of external forces is equal to the mass of the system multiplied by acceleration of the center of mass. Now, when this external force is zero, then we arrived at the conclusion that acceleration of the center of mass must be देख नहीं अभी कुछ नहीं है the acceleration of the center of mass must be zero, and if acceleration of the center of mass is zero, then the velocity of center of mass must be constant. And if velocity of center of mass is constant, then by definition, the quantity m1 v1 plus m2 v2 plus m3 v3 must also be constant. Right? That is the logical succession of steps from where we got the law of conservation of linear momentum. Now, unfortunately, no such logical succession of steps exists in which I can, arrive at a quantity called uh, angular momentum. Okay? I mean, I can do some circular definitions. I can say that look, the torque is equal to the rate of change of angular momentum, or I can do something like this, which is really forcing the thing, but I can say that look, F external is equal to P by dt. Right? We know this. F external is equal to rate of change of momentum. So I can do R cross F external is equal to R cross dP by dt, which I will write as d by dt of R cross P. And then I will say that look, R cross F external is nothing but the torque, and this must be equal to d by dt of R cross P. And then I will say that look, if the external torque on a system is zero, then this implies that this quantity R cross P must be equal to constant, right? And therefore angular momentum is R cross P, right? So this is one way. I don't think this is a very efficient way, because R cross dP by dt is equal to d by dt of R cross P is a very taking a big leap mathematically. But okay, this is an acceptable way of telling you what is angular momentum. Right? So angular momentum is 9. Angular momentum is some quantity of a system which remains conserved in the absence of external torque. Okay? So external torque अगर zero है system के ऊपर, this quantity called angular momentum of the system will remain conserved. It will not change with time. It will remain constant. Now, like I said, these series of steps that I have written is really insufficient to describe the importance of angular momentum in physics. In fact, angular momentum turns out to be much more important than linear momentum in physics. As you already know, that at the atomic level, angular momentum turns out to be quantized, and the unit of angular momentum is h upon 2 pi, right? Planck's constant upon 2 pi. So even when this fan begins to rotate, or if I stop the fan, if it stops, it turns out that it will rotate in increments of this unit of angular momentum. But for us, since Planck's constant is very small, therefore for us it is not noticeable that the angular momentum of the fan is increasing in steps. We do know that this thing, when conserved, gives us a lot of useful uh, outputs. One, the most famous, or the best example that I can think of is something called a gyroscope. We will not be studying the gyroscope because it is beyond our syllabus. But a gyroscope is a device in which the angular momentum of an object is conserved. And because of conservation of this angular momentum, the axis of rotation of the object does not change. What happens is that if you get that object rotating through external means and then you leave it, then that object will be rotating in a particular direction. The axis will be like this, supposing it is rotating like this. The axis will be like this, and the axis will never change, no matter what you do, provided, of course, there is no external torque on the system. Since the axis never changes, therefore that particular direction never changes. So if I were to rotate that object in such a way that the axis is pointing towards north, then it will always point towards north. That is one way in which planes find direction. Now, of course, things are very modern, so they have better devices. But at least 15, 20 years back, the gyroscope was the device which used to uh, tell which direction the planes are moving, or at least it used to tell that, look, this is north for sure. Okay. So angular momentum is a fundamental quantity of nature, and it is conserved under certain conditions. Now, if you look at the physics that we have been studying up till now, it is all about the application of conservation laws. Work energy theorem, conservation of energy, conservation of linear momentum. And now finally we arrive at conservation of angular momentum. So basically, you are going to have five things in your mind, okay, forever, or at least until you give the final exam. So the five things are how to apply Newton's second law for translation, how to apply work energy theorem. Number three is how to apply Newton's second law for rotation, torque is equal to I. Okay. Number four is how to apply law of conservation of linear momentum. And number five is how to apply the law of conservation of angular momentum. These five things are the bedrock of mechanics, and they go beyond mechanics, right? So in electrostatics, you'll find it. In magnetism, you will find it. In every chapter, you will now find the application of these five things. Okay. So this is the last conservation law that we will discuss. Okay. So where is angular momentum coming from? Well, angular momentum is coming from the rotation. So angular momentum has roots in rotation. However, it does not mean that a body should be rotating for it to possess angular momentum. For a body to be in possession of angular momentum, as this expression is telling us, a body must have some linear momentum, and it must have a position vector from some origin. Right? So just like torque, then the angular momentum is also dependent on the origin that you choose. So angular momentum is not an absolute quantity, okay, in the sense that uh, I may choose the origin somewhere else, you may choose the origin somewhere else, and for you the angular momentum may be something else, for me it may be something else. In fact, it may be so drastic, just like torque, that for you the angular momentum is zero, and for me the angular momentum is non-zero. ऐसा भी हो सकता है. Okay. So where is angular momentum coming from? Well, it is coming from the motion of the object. Right? Okay. If an object is moving, then we will say that the object possesses angular momentum. Okay? It is not necessary that the object must be rotating. If the object is rotating, then definitely it possesses angular momentum. But if the object is moving in a straight line, linear motion अगर हो रहा है, then the object may possess angular momentum depending on your choice of origin. Okay, so what are the details about angular momentum? Well, what you have to remember, details are very, very simple. Number one, हाँ वही जोएब ना, तभी मैंने बोला ना कि अगर एक बॉडी लिनियरली मूव कर रही है तो उसके पास एंगुलर मोमेंटम हो सकता है, राइट? If you choose the origin in such a manner that r is not parallel to p or r is not 0, then the object may have angular momentum, no problems. But if a body is rotating, then the body will definitely have angular. This is very weird because up till now what was happening is that the translation वाले डोमेन अलग था और रोटेशनल वाला डोमेन अलग था. अब क्या हो रहा है कि एक बॉडी ट्रांसलेट कर रही है तब भी उसके पास एंगुलर मोमेंट. This is very weird. That is why I prefer to teach this at the very end of this topic. Okay. Okay, so what are the details about it? The details are actually quite, I think we already know most of these. So this symbol for this will be L. It will be a vector quantity and it will have units of kilogram meter square. This will be the units. So I need to now tell you 4 things. You need to remember 4 things. Number 1, how to find the angular momentum of a translating object. Number 2, how to find the angular momentum of a rotating rigid body. Number 3, how to find the angular momentum of a body which is translating and rotating. And number 4, how to conserve angular momentum, right? Because at the end of the day, it is a conservation law, and just like conservation of linear momentum, there is going to be some event, and before that event, we are going to measure the angular momentum. After the event, we are going to measure the angular momentum, and hopefully we'll be able to equate, right? बात तो क्या बोल रहा है मुझे समझ में नहीं आ रहा है क्योंकि मेरे को मॉडर्न शॉर्ट फॉर्म्स नहीं समझ में. आई ओमेगा, अच्छा ये बोल रहा है. आई डब्ल्यू क्या मैं सोच रहा हूँ. बी राइट बैक बी आर बी होता है और क्या होता है. एक और मैंने पढ़ा था, योलो, यू ओनली लिव वंस. आई डोंट नो अगर इसका कोई और मीनिंग है. आई ओमेगा लिखा दो मेरे पास. वाह. हाँ, so mv is the linear momentum, so there must be a corresponding angular term for that, and that should be I omega, right? But we will not come to I omega immediately because, like I said, this is weird. It is weird because even translating objects have or can have angular momentum. Okay? So please try to understand what I'm saying. Try to absorb what I'm saying, and at any point you think things are going above your head, please stop me and I will repeat myself, okay? Or at least I'll try to explain in some other way. Okay, so finding angular momentum. Finding angular momentum. So like I said, finding angular momentum we'll be doing of 3 things. Number 1 is translating objects. Number 2 is rotating objects. Number 3 is translating plus rotating. May or may not have angular momentum मतलब एकदम minute होगा. नहीं 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 नहीं. May और may not का मतलब हुआ, may और may not का मतलब हुआ literally जो मैं बोल रहा हूँ उसका angular momentum हो सकता है, angular momentum नहीं हो सकता क्योंकि angular momentum is a object, is a property, is a physical quantity which is dependent on your choice of origin. So you may choose an origin. नहीं कोई range नहीं ना. हाँ हाँ yes पार बिल्कुल सही. कितना भी बड़ा या छोटा हो सकता है. हाँ. Can we say that a translating body revolves around a circle of infinitely large radius? Yes, we can. Yes, we can. But that does not help our case in any way. I mean, of course, you can say that a straight line is a part of an infinite circle, but that does not mean that your object is rotating. Okay? I mean, that does not help our case in any way. So it is not possible for me to tell you a formula involving the radius of rotation. Okay? Because if you put r is equal to, if you think that you will put r is equal to infinity in that formula and you will get the angular momentum of a particle moving along a straight line, then that would be wrong. You will not do that. You will not get it. Okay? That is why angular momentum is weird. अभी तक हमने जो भी क्वांटिटीज देखी हैं वो रोटेशन के लिए अलग और ट्रांसलेशन के लिए अलग. हाफ आई ओमेगा स्क्वायर आप एक ट्रांसलेटिंग बॉडी के लिए नहीं निकाल सकते. आप उसके लिए बोलोगे हाफ एम वी स्क्वायर. लेकिन यहाँ पे ट्रांसलेटिंग बॉडी के लिए एंगुलर मोमेंटम निकाला जा सकता है. Okay, so for translating objects, okay, for translating objects, so angular momentum is found just like torque. Okay. So what you do is that step one, you draw the momentum vectors of all particles, okay, or center of mass of rigid bodies if they are translating. Okay. So let's see then. We have particle 1. This is moving with a velocity of 2 meters per second and it has a mass of 3 kilograms. हाँ स्मिथ रुक जाना. एनवीआर नहीं होता है बेटा, अभी एनवीआर नहीं आया. फिर this is a body of mass 1 kilogram moving with a velocity of 5 meters per second. Body 2. Body 3 has a mass of 2 kilograms and is moving with a velocity of 4 meters per second. Like this. हाँ बिल्कुल सही. Yes. Now step 2. Step 2. Choose the origin. So let me choose the origin to be, I don't know, somewhere here. Okay. Now I am drawing the XY axis, but it is absolutely not required. Okay. Drawing the XY axis, but it is not required. So XY axis not required. Okay. Step 3. Extend the momentum vectors. And now you see that I have not really drawn the momentum vectors. I have simply drawn the velocity vectors. But you know that the momentum vector will be the same, right? In the same direction at least. So this guy will have magnitude 6 kilogram meter per second. This guy will have magnitude 5 kilogram meter per second. and this guy will have magnitude 8 kilogram meter per second. So these are the momentum vectors. Now what I'm supposed to do is that I'm supposed to extend these momentum vectors, just like we extended the force vectors, both directions. Okay, and then we are supposed to drop, just like in force, just like in torque. Step 4, drop perpendicular on the extended momentum vector from the chosen origin. Right? So what I do is then I choose. What I do is I drop a perpendicular from the chosen origin onto this. I will call this R1. I will call this R2. I will call this R. Same like torque, exactly like torque. Okay, and then step 5, angular momentum is given by linear momentum multiplied by this perpendicular distance. Linear momentum multiplied by this perpendicular distance. Linear momentum multiplied by this perpendicular distance. Now you will see that I have not put any signs plus minus. So for that, we do the exact same thing as top. So put the pen on the head. Put the pen on the head of the momentum vector. Sort of turn it towards the origin. पहला वाला clockwise turn हो रहा है, तो इसको अपन लिख लेंगे clockwise. दूसरा वाला ये रहा momentum vector का head, turn it towards the origin. एंटी क्लॉकवाइज टर्न हो रहा है, तो यहाँ पे हम एंटी क्लॉकवाइज लिखते हैं. And finally, we put our pen on the head of this vector and turn it towards the origin. So this is clockwise. So we will write here clockwise. And just like torque, we will take either clockwise as positive or anti-clockwise as positive, depending on the situation. So here we have M1 V1 R1 minus M2 V2 R2 plus M3 V3, right, which you can write as P1 R1 minus P2 R2 plus P3 R3. I hope nobody is getting confused here. The definition of angular momentum for a point particle is R cross P. So definition of angular momentum for a point particle, R cross P. R is the position vector of particle from origin of choice. P, linear momentum of particle. So please note this down. I hope everything is visible on the screen. छोटा तो ज़्यादा छोटा तो नहीं हो गया? मेरे को तो नहीं दिखाई दे रहा. हाँ, if the vector passes through the origin, then angular momentum for that particle is 0. Yeah, I will write this. Please note this down. लास्ट क्लास के नोट्स मैंने भेजे तो थे किसी को? मैंने भेजा है लास्ट क्लास का नोट्स? नहीं भेजा है? मैंने भेजा है यार, मेरे को याद भी नहीं रहता। I don't know. Somebody tell me. Nobody's got it. हाँ सर, भेजा है हाँ। हाँ, ग्रुप पे भेजा है मैंने, देखो। अगर नहीं भेजा है डोंट वरी, मेरे को अभी क्लास के बाद ना व्हाट्सएप पे वो करना, मैं भेज दूंगा। अगर मेरे पास फोन पे है तो भेज देंगे, क्या बात। ओके, लिख लिया सबने? सो कैन आई स्टार्ट विद क्वेश्चंस? Oh, so I'm assuming that you have written. So let me start with the first question. particle of mass m is projected from the origin with velocity v naught angle theta. Find angular momentum of the particle at the highest point with respect to origin. Oh, very nice, very nice. Yes. Okay, so we want, can't hear me? मैं कुछ बोलूंगा ही नहीं तो क्या सुनाई देगा. So what we want is that we want to we want to find the velocity. We want to find the angular momentum about this point when the particle is at highest point. Right? I hope everybody has यहाँ तक सबने किया है. Then we simply draw the momentum vector mv naught cosine theta. And then we extend the momentum vector. Then we extend the momentum vector. And we drop a perpendicular from our chosen origin. So angular momentum will be equal to linear momentum multiplied by this perpendicular distance, which is nothing but the maximum height of the projectile. Anybody remember maximum height? कितना होता था?
uy square by
uy square by 2g.
V naught square sine square theta by 2g. So this would be mv naught cube cos theta sine square theta. This would be the angular momentum. बिल्कुल सही, यस। सोनल बिल्कुल सही, पार्थ बिल्कुल सही। बी 3,2 है। वो फॉर बोथ एंड द सेम आंसर आ रहा है। अजीब सा है, बट सेम तो नहीं आना चाहिए, आई डोंट। तो हाँ, सेम है, हाँ। नहीं, हाँ सेम। हाँ। अब अगर मैं आपको बोलूं कि जितने लोगों ने मुझे आंसर दिया है, ये सारे आंसर इनकम्प्लीट है। मैं इनकरेक्ट नहीं बोल रहा हूँ, मैं बोल रहा हूँ कि ये सारे आंसर इनकम्प्लीट है। ऐसा क्यों है और उसका क्या इलाज है? हाँ, वेरी गुड। हाँ। हाँ। नहीं, धनुष है, गलत आंसर है। नहीं नहीं, ग्रेविटी नहीं, नहीं। हाँ बिल्कुल सही था, यस। डायरेक्शन नहीं पता है ना, आई नो, I haven't told you whether it's going up the straight line or down the straight line. One case it will be clockwise, in the other case it will be anti-clockwise. That's it. That is the only difference. So ऐसी straight line आएगी. And if I want to find from the origin, then I have to drop a perpendicular from the origin. And I know that length of perpendicular from 0, 0 to uh, minus 2x plus 3y minus 5 is equal to 0 is mod of 0 plus 0 minus 5 upon root of 2 square plus 3 square, that is root of 13. 5 by root 13. Therefore, the angular momentum for part A will be equal to plus or minus, because I don't know whether the particle is going up or down. I don't know this. Plus or minus 5 root 13 mv. Please excuse me. B. Length of perpendicular from 3, 2 to minus 2x plus 3y minus 5 is equal to 0 will be equal to mod of minus 6 plus 6 minus 5 by root 13 is equal to 5 by root 13. So again the angular momentum will be plus or minus 5 mv. Similarly, C, we want to find the length of perpendicular from minus 2 comma 1 to minus 2x plus 3y minus 5 is equal to 0. This will be equal to plus 4 plus 3 minus 5 upon 13. Right? I hope I'm doing this right. 2 by root 13. Angular momentum is plus minus 2 mv. Okay. Okay. So basically, all I'm doing is I'm trying to force you to find the perpendicular distance. That's it. Whether you find this out by geometry or जो है अगर डायरेक्शन दिया अगर मैंने बोला रहता कि नहीं वो ऊपर जा रहा है तो यू कुड हैव सेड समथिंग अच्छा ठीक है क्लॉकवाइज रहेगा नीचे जा रहा है तो एंटी क्लॉकवाइज बट मैंने दिया ही नहीं है ना जब मैंने मेंशन ही नहीं किया है तो यू वुड कंसीडर बोथ द केसेस ना ठीक है ना ओके फॉर एवरीवन angular momentum of a rotating rigid body. Very, very simple. Angular momentum of a rotating rigid body is I moment, where I is the moment of inertia about the axis of rotation. Right? What does this mean? क्या मतलब हुआ इसका? तो rotating body का क्या मतलब? What is the meaning of a rotating? So if a rigid body is rotating rigid body implies that one point on object is fixed. Right? The point does not really have to be on the object, but one point is fixed. And I is found about this fixed point. ठीक है इसमें इसमें कोई डाउट या कोई कुछ किसी को नहीं होना चाहिए क्योंकि यहाँ पे कोई एम्बिग्युइटी नहीं अगर एक ऑब्जेक्ट लीनियरली मूव कर रहा है तो उसका लीनियर मोमेंटम mv होता है मास इनटू वेलोसिटी उसका जो रोटेशनल काउंटर पार्ट होएगा दैट विल बी दैट if an object is if a rigid body is rotating then the rotational counterpart of linear momentum will be m की जगह I आएगा और v की जगह ओमेगा आएगा okay? So let's do one more question. So we have a disk and it is rotating about the point P, where this distance is r by 4. बोथ रोटेशनल एंड ट्रांसलेशन में दोनों एल का वेक्टर सम करेंगे. नहीं नहीं, थोड़ा डिफरेंट है, थोड़ा डिफरेंट है, इसीलिए मैं आखिरी में इसको बताता हूँ. सो दिस इज द एक्सिस ऑफ रोटेशन. फाइंड angular momentum of disk about a dash. Mass is m, radius is r, angular velocity is omega. Very good, Radhika. बिल्कुल सही. हाँ बिल्कुल सही. Absolutely right. Yes. So this is basically you have to find I. Right? I mean that you're not really finding angular momentum, you're just finding I. So I about O dash is mr square by 4. So I about A dash is equal to mr square by 4 plus mr square by 16, which is 5 mr square by 16. Therefore, the angular momentum is 5 mr square by 16. Clockwise. हाँ यहाँ पे clockwise एंटी क्लॉकवाइज नहीं करेंगे बिकॉज वो 3 डायमेंशन ऐसा आ गया है ना. The angular momentum is actually here. Curl your fingers of the right hand along the direction of rotation, and the thumb gives you the direction of angular momentum. Okay? Always, always. In this case, angular momentum will be like this, minus I cap. Okay, I think I will stop here because मेरे को थोड़ा सा तबीयत ठीक नहीं लग रही है. I will stop here. Continue in the next class. ज़्यादा बचा नहीं है, ये खत्म हो जाएगा. हाँ लेफ्ट की तरफ डिस्क, हाँ डिस्क। इतनी तबीयत भी नहीं खराब है कि मैं हॉस्पिटल जा रहा हूँ, बट थोड़ा सा। ये इसके बाद भी क्लास है क्या? शुड आई?
No, sir.
No, sir.
Thank you, sir.
हाँ नोट्स, नोट्स में भेज देते हैं। नोट्स पिछली बार भेजा था मैंने, अच्छा एक ग्रुप में भेजा था, एक में। मेरे को भाई कोई जिसको नोट्स नहीं मिला है, प्लीज सेंड मी अ मैसेज ऑन व्हाट्सएप, आई जस्ट सेंड द नोट्स। बाय बाय।
Bye, sir.